How's it going, everyone? In today's video, we're going to learn about generator expressions in Python and where they're useful. But before we begin, I'd just like to thank Zed for sponsoring today's video. Zed is a lightning-fast code editor written in Rust, and I use it to do all my coding now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. By this point, you're probably very familiar with list comprehensions. They save us the trouble of having to create variables and a for loop for very simple operations. For example, this code snippet can be simplified to this one over here, which is incredibly convenient. And I say very simple operations because if you decide to try to stuff a complex for loop operation into a list comprehension, you will end up with some illegible garbage. For example, I prefer this for loop approach over this list comprehension approach. The list comprehension takes far too much effort to understand here. I'd really rather keep the logic simple using a regular for loop. But this video isn't about list comprehensions, it's about generator expressions, which I often refer to as generator comprehensions since they mimic the syntax used for list comprehensions. Generator expressions allow us to create generators using the same syntax that we'd use for list comprehensions. Let me show you how we can create a simple number generator using a generator expression, and then compare it to how we'd create a regular generator. And for this example, I'm going to import the generator type and the iterable type. To create a generator expression, all we need to do is use parentheses instead of square brackets when writing the expression. Then we can use it as a regular generator. As you can see, when we run this, we will get the next three numbers back from this generator. It's that simple. Creating a regular generator takes more effort. As you can see here, first we need to define the function, and then we need to create the logic. And in this case, I'm just using a regular for loop and yielding the number for each element in this range. Comparing it to what we had earlier, you'll see that this is far more verbose. Not to mention that if we want to use it, we still have to create an instance of it. And then we can call next on that instance as many times as we like, or until we exhaust the generator. While with the generator expression, we could just call next on it immediately. So, why would you ever want to create a regular generator over a generator expression? Well, just like with list comprehensions, if your logic ever becomes more complex, stuffing it all in a generator expression makes it very hard for the remaining humans that have not been replaced by hallucinating AI agents to read it and to modify it. Another drawback is that a generator expression is basically a one and done deal. This means that you can't really create more than one of the same generator without complicating the logic in your codebase. By defining a generator the function definition way, we make it possible to start as many generators as we need. As you can see here, with a generator expression, we essentially have only one generator that we can work with. But if we were to create a regular generator the function definition way, we could create as many generators as we like, and these are all separate generators. What's the point of having a generator expression then? When would you ever want to create a single-use generator? Well, in some cases, it will be the cleanest way to insert values into a function without having to use another container type first. For example, here we have a function that calculates the sum of a sequence of consecutive integers directly. As you can see inside the sum function, there was no need to create a list comprehension first to pass in those values, which in my opinion is much cleaner than passing in the list comprehension. And in the end, we get the same result. Another reason to use generator expressions is that it saves on memory, since you are not loading anything into memory until you actually request it. To show you what I mean, I'm going to import system, then I'm going to print the size of a list comprehension and the size of a generator comprehension in bytes. Both of these comprehensions contain the same information, but the list comprehension materializes the data immediately, aka loads it into memory, while the generator expression waits until we explicitly request the values. It's important to note that saving on memory doesn't mean that the function will perform faster. If we have to load all the data into memory at once, it will take around the same time as using a list comprehension, or it might even be slower since yielding values one by one is a slightly more expensive operation. At the end of the day, do your best to pick the right tool for the job. Whether you pass in a list comprehension or a generator expression to a function isn't a detail that matters on a small scale. What matters is that you understand that one is used for instant data and the other is used for lazy data. And again, I really enjoy the generator expression approach for functions. It removes clutter and looks very Pythonic. Once again, here we have the generator expression approach and the list comprehension approach. And when we run it, we end up with the exact same result. And I honestly really appreciate this approach. Even if I wouldn't go as far as to say it was a life-changing experience, I still appreciate it. But that's enough about what I think. I'd love to hear what you think about generator expressions and how you usually use them. Otherwise, with all that being said, thanks for watching and I'll see you in the next video.